Okay guys, this is the video for Unit 3.1. We are, for the time being, done with two-column proofs until later, but all the two-column proofs going forward are a little less abstract. So let's look at the couple of definitions here. Parallel lines. Parallel lines are two coplanar. Remember the word coplanar, meaning there we go. How do you spell? There we go. Coplanar lines that do not intersect. So it's two lines that do not intersect each other, and these two lines have to be coplanar lines, meaning they're on the same plane. Okay, and if you notice that there are little arrows on it, they're used to indicate that these two lines are parallel, and these are these two arrows. That means line AB and line CD are parallel to each other. CD, and I'll change the color. We use this symbol to represent that the two lines are parallel to each other. Okay? Parallel planes are planes that do not intersect with each other. And in this case, we can do the same thing. Plane J is parallel to plane K. Now, notice that how we use one letter at the corner of the plane to denote the entire plane, but when we write it out in English, we have to use the we have to spell it out, and that's because if I just use J, I probably will get it confused with a point on that plane. Okay. Skewed lines. Skewed lines are a little bit more challenging. That they are non-coplanar, meaning they're not on the same plane. Non-coplanar lanes that do not intersect. So if you compare this with parallel lines earlier, when we talked about, the difference is that in this case they're not on the same plane. So for example, if I give you PS here, this one on the side, and VR, right? VR is in this plane right here, UVRQ, and RS is in the other plane that parallels to UVRQ. However, they don't intersect, they don't parallel, they have no relationship, they're not on the same plane no matter how you do it. Okay, so the example we did was PS, in this case it's a segment, and we did VR. Now if I point out a couple of other examples, if you look at TW, let me change the color here, TW is that green line there, and UQ, and this pair. So TW and UQ, they are skewed lines as well. Okay, and PT, if I do PT, this one in the front, the black one, PT, and QR, this one on the side, is the same thing. Okay. One question I want to point out is that what if I'm talking about VR, this yellow line, and TP? They're obviously, it looks like VR is on this plane and TP are on this plane, but in fact they are parallel. And the reason for that is that I can slice this block diagonally, and there is a plane that I'm creating sideways. It's almost like sliced cheese, right? And in that case, those two lines are parallel. Okay. Here are some examples. Let's see. in this block, we're asked to name all the segments that are parallel to AE. AE is right here. Should do a more obvious color right here. AE is right here. So we're looking for all the segments that are parallel to AE. So I think BF, that's one, and DH is one, and CG is another one. Next, give two examples of parallel planes. So that's easy. I have plane ABF and plane DCG, right? I have plane ADH, parallel plane BCG. And C, name all segments skew to the segment GH. And let's see again, GH is right here. If I look at so I'm looking for all the segments that are skewed to the blue segment GH. And I would say it's FB and EA, AD, and the last one would be BC. So make sure that you pause this video and verify every single one of them that I pointed out is true. Okay. One last example. In this diagram, we have to name all the lines, all the segments that are parallel to JK. JK is here. So all the lines that are parallel to that, I think the only thing I can see is this parallel is this PQ here, or I'm sorry, this is OP here, right? I don't have any other, there's nothing in this plane, only at the bottom, OP is parallel to that. And next, name all segments that are parallel to NS. NS is right here. So there are several. I have JO, I have KP, I have LQ, and I have MR, right? C, name a plane parallel to plane JKL. If I have JKL, I can do PQR. So plane PQR would be parallel to JKL. Name four segments skewed to RQ. RQ is here. So I have to find four segments that are skewed to it. I have JO, I have JK, I have JN, and finally I have PK. All right. So that was some exercise more to train your three-dimensional thinking. And here is a very important concept called transversal. A transversal is simply a line that intersects with two more lines. And so in this example, we're talking about line T here, which is this one, right? Notice that if I were to extend this line and use a different color, so if I were to extend the yellow one and the green one eventually, they will also, let's see, nope, it's this one. See, they will eventually intersect with each other as well. So So the green one will intersect with blue and yellow, and so the green one would also be called a transversal. Probably the easiest thing to remember what a transversal is, this actually came from one of my previous students who said it really is just the line. If you have a fence like that, it's the line that cuts through the fence. So that's definitely line T is my transversal there. Okay, so with transversal, it creates several definitions. Let me see if I can make this bigger, first of all. Oops, that's too big. I wish there's a way to make it, what if I shrink this? Nope, it doesn't work. Okay, we'll make do with it. So it creates these four groups of angles. So again, if I have a transversal, again, transversal is simply the line that intersects with two or more lines. So once I have a transversal, it creates four groups of angles. Corresponding angles are the angles on the same side of the transversal in the same position, meaning angle 1 and angle 5. So if you look at 1 is here, 5 is here, right? And by the same token, angle 2 and angle 6. So if I use red, angle 2 is on top of the first line, angle 6 is on top of the second line, right next to the transversal. And I can also have angle 4 and angle 8 are corresponding. So 4 and 8 are here, and they are, make them smaller. 4 is the yellow one, 8 is the yellow one. They're right underneath. And finally, I have 3 and 7 who are corresponding to each other because they are right under each line, each first line, second line, to the right of the transversal. So that's one set of angles called corresponding angles. Then there's alternate interior angles. Notice the word alternate means alternate around the transversal, meaning on different sides of the transversal. So interior is meant for this part. It's between the two lines that we're discussing. So ultimate interiors are interior angles non-adjacent and on opposite side of the transversal. That's the definition here. So by that definition, we have angle 4 and angle 6, right? So if you look at 4 and 6, 4 is here, 6 is here. And of course, angle 3 and angle 5 are also alternate interior angles. If we have alternate interior angles, we must have alternate exterior angles. And over here, beyond the first line and below the second line are the exterior angles. So, and they're simply what this small print says. They're exterior angles, they're not adjacent, and they're on the alternating side of the transversal. So in my example here, I would have angle 1 and angle 7 and angle 2 and angle 8. Okay. Finally, the weirdest one in my opinion is called the consecutive interior angles. And they're interior angles right next to each other, basically. They're on the same side. So if you look at angle 4 and 5, I erase this here. If you look at angle 4 and 5, they are on the same side and they're interior. And by the same token, angle 3 and angle 6. All right, so this part is pretty self-explanatory. I have posted the answer keys on the website, so you can just go to the answer keys and figure out what the answers are. If you have any questions, bring it into the class and we'll discuss it then. Thank you guys. Bye bye.